Good morning. My name is Unspa, and my project is multi-agent self-driving simulation in double merge scenario. And my mentor is Seung-il Kim. He's here. This is my presentation contents. First one is about me. Second is introduction and project purpose. And I would like to say about my configuration of simulator and DDPG and Git repository. First slide is describe about me. I have some experience to teach university students in United University with my professor about CNN, and I also I'm a team leader of autonomous vehicle team, and I have some short experience in startup, the visioning. At the time, we are developing software application for customer service using computer vision based on face recognition. So I would like to start with a question: why we need multi-agent simulation in self-driving environments? Let's see the video. As you can see in the video, driving is actually the multi-agent game. We have to figure out drivers have to know other drivers' purpose, like overtaking, give way, merging, taking left or right turn, and so on. And this is another video. This is Mumbai, known as terrible traffic. As you can see in the video, there are so many pedestrians, vehicles. So in this case, driver should figure out pedestrian purpose. And if you make your agent manually taking all possible cases, the agent maybe get too simple policies. And the balance is very important. The agent should be balancing between unexpected behavior of other drivers or pedestrians and not to be defensive, since normal traffic flow have to be maintained. The most important thing, we need simulation because we do not have much money, and self-driving car testing is dangerous. Even Google self-driving car sometimes crashes into a bus. There are three elements of autonomous driving. The first is sensing, and second is mapping, and the last one is driving policy. In this project, I would like to focus on the driving policy. So in this project, I would like to make multi-agent self-driving simulation in double merge scenario. As you can see in the picture, double merge scenario is very dangerous, so we need to simulate it. In this case, the driver might want to take up this road and saw that the rightmost lane was empty, like this, and so the driver was moving to the rightmost lane, but the driver is crashed. This is a video of this picture. The driver wants to take the rightmost lane, but there is a car. So double merge scenario is very challenging, and we have to solve using simulation. This is a detail of my simulation scenario. Vehicles approach the merge area from both left and right, and vehicle can decide whether to merge into the other side or not. In this picture, green car have to get to green zone, and yellow car have to get to yellow zone. So I surveyed some simulators which I hacked. So I can find some simulator. The first one is deep driving from Princeton University. They suppose 3D game-like environment, and they can convert the viewpoint to the bird-eye view. And the second one is deep traffic. I saw it from the MIT self-driving car course. And the third one, this is from Kyushik. He's my roommate. So you will see this simulator soon. I decided to make my simulator because a double merge scenario, I cannot find the double merge scenario in previous simulator. So this is my simulator configuration. The actions page is 3, steering, acceleration, and brake. And state is 12 dimension. Color of agent and car body position, angle, velocity, and 7 sensors like this. 1, 2, 3, 4, 5, 6, 7. The most important thing in RL and in simulator is the reward function. Reward can be separated according to the situation. In driving case, I design my reward like this. It's simply a projection of the vector. So my target point is 2 for each agent. So in this case, projection is like this, and this one is like this. So I apply max. So this agent want to get to target 1 because this direction, in this direction, the agent get more reward. The target point is like this. Reward 2 is in case of the agent to get to target. I just put 500 when the color of the agent and the target color is matched. And the color mismatched, I just put minus 500. And I also include get back to start position function. So I want to train continuously. And in case of collision, I just put minus 600. So this is my network design. This is the first approach. So I want to correlate all agents stick to their way. I want to apply DDPG, deep deterministic force gradient for each agent, and all agents share the network parameters. The agent, the purpose of the agent, the car, is very similar, and just they get to the target. So I can share the parameters. I design only one network. In this slide, I would like to introduce some reinforcement learning concept. Before I came to this camp, I saw the YouTube video recorded by Professor Kim. So, and I'm relatively new to reinforcement learning. So, if I make some mistake, please correct it. And this is the basic concept of reinforcement learning. There is a state and action and environment. The actor network select, take the action, and then environment put the new state and reward. This is repeated. New state and action environment. What I really want to make is an actor network. So using reward, we want to update the network to get better rewards. This is a basic concept of reinforcement learning. So important thing is how. In actor critic method, critic network evaluate the actor's actions. So we need to think about this. Taking an action, getting maximum reward at current state is always good. You guys already know the story of marshmallow. There are two children. Someone said that if you're not eating for 20 minutes, I will give you another marshmallow. So we need to think about the future reward. This is another example. If the mouse just follow the part of cheese, he will get trapped. But right side there is a huge cheese factory over the forest. So we need to always think about the future reward. So in this basic reinforcement learning configuration, we need to think about the future expected reward. This part is show me the future part. So the critic network evaluate my action, the painted blue, action that will get better expected future reward. So this process can be in mathematical form like this. It looks a little bit complicated, but I matched the color. The state is red and action is blue. So the reward is a function of state and action, this part. And second term is like this. The output of critic network, this one is new state, and this one is new action, the input of new state, and this one is critic network. So all of these things is the expected future reward. This is loss function. It is also seems a little bit complicated, but this one is YT, the future reward, future expected reward, and this one is target. If we decide target, we can simply update this critic network and actor network using seem like chain rule. So the update, the direction of update is like this. We can update this actor network using this formula. And we can think of how about the target. The target network is updated like this, using this formula. It seems like average, moving average. So the update is, the process of update is very slow, slowly changed. This is my network design. I just the FC means the fully connected layer, and the number is the number of neurons. So this one is actor network, and critic network, input of the critic network is action and state. The output of this network, actor network is the input of critic network. So this one is the evaluation of the actor network. This is the detail of this algorithm. If you want to see more detailed description, please see the paper. So I applied the DDPG in my simulator, and let's see the video. This is the initial version. The green agent, the direction of green agent, the upper side is the red agent have to get to the bottom side. You can see the oscillation of the agent. I think that because there is a two goals, so in this line, the reward is very similar, so they have some difficulty to decide the direction. The second one is the video of the result, training board. They move more smoothly, and you can see some agents are fighting to get his way. This is my result applying DDPG, and this video just I include this video just for fun. Let's see the video. I captured this video in the training process. They show some. They looks like jump. So this is a car. But I captured this video from the training result. What I really want to simulate is the centralized learning. I want every agent make their way cooperatively, but the previous case they are fighting to get their way. In this case, more cooperative and safety policy is needed. Okay, I'll skip this video. So, I want to apply multi-agent actor critiquing method from OpenAI. This architecture is very interesting for me. At training time, critiquing network evaluate all actor action with a centralized manner. Actor can learn what to do with the others because of the critiquing network can see all of the action and all of the states. At execution time, only actor network works. Like what human is doing in school. We can think that the critiquing network is a teacher and the actor is a student. So in school, in training environment, critiquing network evaluate every student, but in real life, actor have to decide their way and decide how to do by himself. So we decide, my mentor and I, to apply this mechanism to our double merge scenario. So the architecture is changed like this. This is very simple. this is the same as the previous DDPG process. The only changed thing is this part. Critic can see the new state and new action. And new state. Okay. Thank you. So critic can evaluate each agent according to the other agent action. At test time, we don't need the critic network. But I'm afraid to show this result. This is rule-like rocket. It's not conversion when I apply multi-agent actor-critic method. I try many things, but I just get this result. So what I was trying is I apply batch normalization and Ricky-Rello because I think that the steering is saturated, so I want to apply batch normalization and Ricky-Rello. And the input is increased in critic network, so I thought that we need more deep critic network, so I was trying that. And I also increased in the target reward because they didn't go to the target, they just go to all. So the last thing I was trying is including Euclidean distance to the state vector and removing sensor readings. I thought that sensor reading is not important because in the state network, in the state input, there already has the position information. So I think that I removed the sensor reading. So I reduced the dimension. And what I can try is the bidirectional LSTM for critic network. In previous network, the input size is fixed, so I think that is very difficult to apply in real double merge scenario because the input agent, number of input agent is varying. And I really want to study MADDPG more. This is my Git repository. You can download the source code and simulator. And I would like to say thanks for my mentor, Sung Kim, and Professor Kim, and Bin-Nuri, Jimin, and Kwon-Sun Son, and all of my friends in MLJejuCamp. Thanks.